Good morning, friends. Today we're going to continue our force and motion unit in science by moving forward from push and pull to gravity and friction. And how we're going to do that is we are going to enjoy a couple of videos about a sport called zip lining, which is a great physical example of gravity and friction at work. And then we will complete some questions based on the videos that we watch about zip lining, friction, and gravity. And then lastly, I'm going to challenge you to, at home, complete the STEM activity at the end of our lesson. So let's go ahead and get started with some videos. All right.
You've just read some important definitions. We will now demonstrate these concepts using ground school. As Andrew steps off the platform to begin his ride, gravitational acceleration pulls his mass down the zip line. Andrew accelerates until his maximum velocity is reached. If it wasn't for the opposing force of friction, he could have gone even faster.
So the words that we're going to be focusing on today are friction and gravity. All of those other big words don't worry about. They're showing you that gravity is pulling him down, while friction on the rope and the mechanics of the zip line are holding him back from moving forward faster. So that was just a quick visual of friction and gravity at work. And now you know what zip lining is if you didn't know before. So those other big words that they talked about in the video are explained here. So the force of gravity is what pulls everything towards the ground on Earth. The Earth's core inside of, there's something called the Earth's core inside of the Earth that is the center of all gravity, and that's where everyone and everything on Earth is being pulled to, which is why if you fall off of a swing or the monkey bars, fall down, not up, right? The word mass is kind of loosely another word for weight. So the weight of his body being pulled down. Accelerating can either mean that you're moving faster or even moving slower. And then maximum velocity, don't worry about that in second grade. So friction is that force that's preventing him from going faster. So we've got push and pull. Well, friction is that element that hinders you from being able to push or pull at your highest ability. Here is our next video. These are some questions we can think about while we watch. How did the people move? In which directions did they move on zip lines? And then did you notice anything about changes in acceleration? Acceleration is, for example, if you're riding in the car with your mom or dad and the stoplight turns red, your parents are going to accelerate at a lower speed so that they can stop and keep you safe from opposing traffic. Similarly, when the red light turns green, your parents are going to accelerate in a positive direction, and their speed's going to go up to the speed limit. So think about what it's basically asking is think about the speed at which these people are going. Are they going faster as they go along the zip line? Are they slowing down? What's happening to their speed? And what do you think causes that change? Full screen is unavailable. Fantastic. See if we can just go to YouTube. That'd be great. All right, guys. Let's see if we can skip this ad. Hang on. Sorry about that.
First opened in 2007, and we've just cleared 40,000 people. We are the only zip rider with 6 cables side by side.
It's not only the thrill and the excitement of the speed of the ride, it's the view.
Ready for this? Whoa, that zip line is taller than the Empire State Building.
Feels like you're floating. Feels like you're floating on your way down. The biggest reaction is they're surprised that
Notice their
it's not as
speeds.
scary as they thought it was going to be.
I have several people that come to the fish house and they want to go again. It's an experience of a lifetime.
Right. So I'm gonna actually go back to where they are. Let's move me out of the way here. Going down. Let's see. All right, I think it's about here. Watch their speed as they go down the hill. They're going pretty fast, huh?
The biggest reaction is they're surprised that it's not as scary as they thought it was going to be.
I have several people that come to the fish house and they want to go again. It's an experience
Now
of a
notice their
lifetime.
speed. Their speed slowed down at the end, if you noticed. Let's take a look at some of our questions. So what we're going to do is we'll read this short little article on zip lines, and we'll answer some questions based on the videos we watched and based on the article we're reading together. All right, a zip line helps people or objects travel from a high place to a low place by sliding down a cable or a strong metal rope. Some people use zip lines as a fun ride. Others use it to travel over dangerous land. But all zip lines use force to move. A force we know by now is a push or a pull. Forces are what make things move. You use more force to push or pull heavier things. You use less force to push or pull lighter things. There are forces you can see, like when you pull a wagon. And then there's forces you cannot see, which is what we're going to focus on today, which is gravity. Gravity is that force that pulls things down to the ground. A zip line uses that force of gravity to make an object move. Forces can make things move, but they can also stop things from moving because of this guy, friction. Friction is a force that can slow or stop an object that is moving. Friction happens when two objects slide or rub together. So this is friction. If you rub your hands together with me right now, you'll feel your hand getting warmer. That's friction at work. If it weren't for friction, my hands would be able to move a lot faster along one another. So friction is that force that can slow or stop an object that's moving. Friction happens when two objects slide or rub together. The two objects grab onto each other, which makes it harder to move. For example, when you walk on rough sidewalk, your shoes have those divots on the bottoms. They're going to grip the ground to keep you from sliding. However, think about if you were to wear your gym shoes on an ice skating rink. The friction is a lot different on an ice skating rink compared to a rough sidewalk. You're going to be slipping and sliding around like crazy on an ice skating rink compared to a sidewalk. The more friction that there is between two objects, the harder it will be to move. So, do you think that there's more friction on a sidewalk Or do you think there's more friction on the ice skating rink? Let's see. There's less friction between smooth things, for example, ice. You slip and slide if you walk on ice because ice has a smooth surface. So ice is going to have less friction than something like a sidewalk. Just a little review. A force is a push or a pull. These are your vocabulary words. You can use less force to push or pull lighter objects, okay? A ball is going to fall down to the ground when it is dropped. Think about it. The reason why is because gravity is the force at work. It's pulling the ball to the ground. Interesting how gravity is an example of a pulling force. That center of the earth, that core, is pulling objects toward it, and the ground stops it from going further. Friction slows down or stops an object from moving. So pretend again, this is a sidewalk and you're trying to push a crate across. There's more friction, so it's going to be harder to push that box across that rough surface. However, if this was an ice skating rink, it would have less friction, so less of a force is opposing you or going against you. So you'd be able to push that crate, no matter how heavy, much easier than you would if it were on a rougher surface. Friction happens when two objects rub together. There is more friction between rough objects. This makes your shoes grip the sidewalk so you don't slip when you walk. Similarly with cars, we were talking about cars earlier. If you notice, or if you have a chance today, check out, make sure that your parents know that you're checking it out. The tires on your family car. Notice how they're kind of like the bottoms of your gym shoes. They have these ridges and edges all along them. That is so that your car doesn't slip around when it's icy, when it's rainy. If the road is more torn up, if it's a newer, smoother road, it is making it a more safe ride for your family because it's providing that friction that's going to keep you on the road where you're wanting to be. And then there's less friction between smooth objects. This makes it easy for you to slip on something like smooth ice. All right, here's where we're going to brainstorm together. And this is what I'm going to challenge you to do at home. If you don't think that you have materials to do this at home, don't worry. Maybe look up another YouTube video. Maybe look up an example of someone who has built their own zipline experiment. Don't worry if you don't think that you have the materials to make it, or if you don't think you have the time to make it. It would be a very valuable experiment, but don't overexert yourself or your parents. So my challenge to you today is going to be to build a zip line, and then also a carrier for the zip line that's going to carry an object. I'm not going to tell you it has to be a ball. You could use a Lego person. You could use a Barbie doll to safety, okay? And then what you're going to aim for is a zip line that's about 4 feet long. So for an average second grader, that'd be about how long it is for you to lay with your arms tucked at your side on the ground. See if you can get the object, whether it's a Lego person, a Barbie, or a ball, across the zip line without it falling, so without it getting injured. I want you to, we already looked at different zip lines. We noticed what they're made of, okay? Think about what they're made of. Think about the forces that are used to make it start and stop. I showed you, again, that video, let's see, when they were taking off. Let's watch it just one more time. I want you to see how they start. I want you to notice if it's the zip line that's making it start or if it's another force at work that's making it start. Did you notice how they were able to get started? So the zip line is angled down towards, again, that center of the earth where gravity is pulling you. I know when I've gone ziplining before, I mean, I wasn't doing a zip line taller than the Empire State Building to start out. So I actually had to push my own body using my feet, kind of like you would on a swing, to get myself started. But this zip line is at such an angle, such a slope downward towards the center of the earth where gravity is pulling you, that all they had to do was just lift their feet up and then they started going down. So think about how they can look. Think about what you would want your zip line to look like. Remember, if lighter objects are going to move at a higher acceleration or faster, easier, with less friction, with more ease than a, see if I can get this up here. There we go. Than a heavier object. Okay, cool. First time using this one. Thanks for bearing with me. So how would you want your zip line to work? How do you think you can make it safe? How do you think you can make it effective? So if you're using something like string and maybe Lincoln Logs or Legos or just anything you can find around you that you think is going to be a sturdy base, you want your starting point of the zip line to be higher than the ending point. Why? Because gravity is pulling you down. So you want to start here. You want to make sure that your zip line is angling down, and the steeper the slope, the faster your object is going to go. This is where you would end. What can you do? What objects can you use to get it from the start to the end without falling off? You'll need to find something like string, like floss, like a shoestring, that's going to provide friction for your object, that's going to be, now remember, a rougher surface causes more friction. It's going to keep your object safer because it's not going to fly down like you slipping on ice. So if you use something like a shoestring or just normal string, it's going to have more friction than if you use something like floss. Think about how waxy, how smooth floss is. Your object's gonna fly down your zip line if you use something smoother rather than using something more rough. You also need to keep in mind, if you're using a Barbie doll over a Lego person, that's a heavier object. So the heavier the object, the more sturdy your the base of your zip line is going to need to be, and the stronger your material for your zip line is going to need to be. Now, we talked about and we listened to what a real zip line is made out of. It has a wood foundation, and the zip line itself is made from metal wire. I really don't want to encourage you to use metal wire at home. If you have a parent or a guardian or a babysitter helping you at home, you guys can come up with whatever you think is safest, but I don't want you doing that on your own. All right, so let's see here. Hopefully you can see my screen. There we go. So this is the document that I've shared with you on Google Classroom. And I want you to think about, we talked about how I would make my zip line, what it would look like. I didn't tell you necessarily materials that I would use, but I gave you some suggestions. I want you to draw what you sketch out like a blueprint, what you think a good structure for a zip line would be. These are suggested materials. If you don't have these objects at home, that's perfectly fine. Again, if you can't make it, at least try to watch an experiment version of someone else who's made it on YouTube. So glue, tape, scissors. Table tennis ball is because they want you to use a ball as your object. You can use a Lego person, a Barbie, stuffed animal. Just remember, the heavier object you choose, the more difficult it's going to be to keep it safe from falling. They also suggested maybe a ruler. Here's some other objects that you could use maybe for like your zip line portion. Rubber band's a great example of something that has a lot of friction. That would be a good one. Some different things that you can use. And then things that you could use for testing. You definitely want to have some kind of a string that's going to connect your two sides, the higher point where you start and the lower point where you end. And then it would be good to have a timer or a stopwatch so that not only can you make sure that your object will safely go across, but also how long it's going to take your object to get from the start to the finish. So what that acceleration is, at what speed is it going. So you will have come up with a plan, make a blueprint, you'll create that design and then test it out. And if you want, you can use different materials, make different kinds of zip lines, use different objects to go across. Because think about it, me going across the zip line is going to be very different than if Mr. Keller goes down a zip line, or if, let's see, Will goes down the zip line. We're all different masses, we're all different weights, and gravity is going to impact us differently on a zip line, okay? So if you use different objects and you use that stopwatch, you can see, ooh, the Barbie doll goes down more quickly or more slowly than the Lego person, or whatever you choose to use. After you've tested your experiment, think about how it worked. It's always important after you do an experiment or conduct any kind of science to reflect on your results. So think about what happened when you tested your zip line and the carrier. Did they work? What could you do to make them better, even if your object safely gets across your zip line, even if you feel like you found examples of an object moving more quickly and more slowly down the zip line? Think about it. If you had better materials, how could you make it better? If you had more time, if you had, resources, how could you make it better? You can always improve on yourself. That doesn't mean you're doing a bad job. You're just reflecting on yourself, okay? So those are the important steps with your zip line. And then this is just kind of a graphic organizer to help you organize your thoughts if you need that structure. So hopefully this will be a fun activity for you. At the very least, if you watch this video, I hope you learned something new about zip lining. It is super fun. If you notice, they were wearing helmets and safety gear. That's a super important part of it, to do it safely. And like I said, if you can't complete this activity at home, at least try it, like just objects that you have sitting around you. Maybe you use a ketchup bottle and a mustard bottle to be your foundation for your top and bottom. Maybe you use fishing line, if you have that sitting around. Maybe you use, like I said, floss. It doesn't matter. Just try to create something at home if you can. If you can't, just watch examples on YouTube. I hope you have a wonderful day. Right now it's not too cloudy, definitely nothing like yesterday, so hopefully the rain holds off. If it does, try to get outside, and if it doesn't, there's always tomorrow. Tomorrow's supposed to be sunny and beautiful for Crafty Friday. I will see you later this evening. We're going to read chapters 23 and 24 of The Mighty Miss Malone. Have a great day. Love ya. Bye.